Hello friends, let us do a nice problem. Here, the circle is given whose radius is 8 centimeters. At the same time, equal parallel chords are drawn in this circle, which are again 8 centimeters apart. Right. Now, what is the area of the shaded region which is enclosed between these parallel chords? Right. Now, equal parallel chords. What does that mean? They they are parallel also, they are equal also. That means they have to lie on either side of the center, because if they are lying on the same side of the center they cannot be equal, right? If you draw one chord here, another chord somewhere here or above this, then it will be either greater or lesser than the first chord, right? So that's why the second chord has to be on the other side of the center only, because it has to be parallel. It has to be on the other side of the center. Otherwise, if it is not parallel, we can draw something vertically also. But because they are parallel, they should be equidistant from the center. Then only they will be equal in length. Right. So, so what does that mean? We can draw perpendicular to these two chords, and the perpendicular length of that perpendicular would be 4. Now to calculate this total area, see, we don't know, there is no direct formula of calculating area where a curve is involved. Right. So we try to do some adjustment to break this area into parts or into structures where we can find out areas using formula, whose areas we can find out like this. For example, we can divide this entire area into four parts, each part like this. Now each part would look like this, and we can break this part into two parts, green one and the yellow one, right? Green one is a pi, and the yellow one is a right angle triangle. Right angle triangle, we know how to calculate area, half into b into h. This pi also we know, whatever is the degree, it is taking that by total 360 into pi r square. Total area is pi r square. Whatever is the angle, if you are able to calculate this angle, that is sufficient. So we can calculate the area of this pi as well as this rectangle. Let's see how we can do this. Rectangle, this height is already, sorry, triangle. In this triangle, the height we already know, right? Total is 8, and the distance between the chords is also 8. That means distance between chord and center is 4. At the same time, the length of the radius, the hypotenuse, is 8. What does that mean? The other side of the right angle triangle is 8 square minus 4 square, whole root of that, right? Which is root 48, which is 4 root 3, right? So we know what is the area of this right angle triangle. Now, if you closely see this angle, this angle is 30 degrees. Why? Because one of the sides is 4 and the hypotenuse is 8. We know sine 30 is half, which is 4 by 8. That means this angle should be 30 degrees. Once this is 30 degrees, obviously this will become 60 degrees. Right? Hmm. Because this is a right angle triangle, this is already 90, this will become 60. Once this becomes 60, this angle will automatically become 30 degrees. Right? This is the angle that we are looking for. Now, if this angle is 30 degrees, what is the area of this pi? Which is, this is 30 by 360 degrees into pi r square. 30 by 360 into pi r square. R is 8. Right? This is the area of this green sector, green pi, which is which when simplified, it gives 16 by 3 pi. So what is our total area? Which is yellow plus green into 4, because such there will be 4 yellows and 4 greens in this entire sector. In this entire region, 4 yellows and 4 greens. So 4 times area of yellow one, which is a right angle triangle, is 8 root 3, and area of this sector, which is 16 by 3 pi. 4 into 8 root 3 plus 16 by 3 pi, which is equal to 32 root 3 plus 16 by, sorry, 64 by 3 pi. Right. So this is the total area. This is a wonderful problem. What we have done, because we directly don't know the areas. There is no direct formula of this calculating area of this sector. We try to break this into figures where we can find areas. We know area of a sector, we know area of right angle triangle. So we try to break this region into those parts where we can calculate area, where we can calculate areas. Right. So this is such a wonderful problem. Hope you like this. Thank you guys.